So hi everyone, welcome back to the developer track. I am Joshua Culp. If you were here previously, I introduced myself then. I am going to be speaking right now and also moderating myself, so it's a little inception at the moment. But as always, if you have any feedback about this, the presentation, or AstroCon in general, please don't hesitate to provide it on the schedule site, or you can catch David Duffett in the hall and promptly tell him anything, and hopefully he'll remember. But right now we're going to be talking about Asterisk 15 and the video support that's gone into it. So this is my colleague Kevin. Let's get started.
Okay. As Josh mentioned, we're going to be talking about Asterisk 15 and some of the new stuff, the video work that we've done that's gone into it, and the journey to get there, as it says. Hopefully we won't be going back again, though. All right. Josh, I guess you kind of already introduced yourself.
Yeah, I'll also, as always, I am on Twitter, so my Twitter handle is JoshNet. If you tweet me, I will respond. But if you ask me a question, you will get an answer, but it may not be an answer you expect. So feel free to add me and talk back.
All right, and my name's Kevin. I am not on Twitter, so I have no Twitter handle. I've been working at Digium, I guess, a few years now. Working on the Asterisk team. Before that, I've just done some various things, project and development-wise. But when I came to Digium, that was my first foray into telephony. So, all right, Asterisk 15 is the next major version of the software that's just been released. Actually, a couple days ago, Tuesday. Today's Thursday. Yeah. As usual, there's been quite a few things that have gone into it, but the bulk of the new changes that have gone into 15 have been about laying the groundwork for true multi-stream media support in Asterisk. And that's what we'll be focusing on here for this talk. We'll be talking a little bit about how Asterisk has worked prior to now in the previous versions and how it continues to work for legacy systems, or legacy users, I should say. We'll also go over some of the changes that have been made to Asterisk in order to facilitate the multi-stream handling, like some of the changes that we've done to the bridging framework and to the channel drivers, specifically PJ-SIP. Since the work we've done for the multi-stream work has been foundational, we'll also talk a little bit about the future endeavors the direction we want to go in, stuff in the to-do column. And we'll talk a little bit as well about some testing we did, specifically how we wrote a WebRTC client to test the new functionality, and if we have time, we'll be demoing that as well. So up to now, how things worked with regards to the flow of media in Asterisk. Lacking a true stream interface, it's basically used just a single pipe for reading and writing frames, where each frame had a type and format associated with it. And you only had a single type for each media type was possible. So for instance, you could only have one audio and one video, but you couldn't have two audios or two videos or anything like that. So in any subsystem needing to interact with the media, had to hook into this pipe and then filter on the media as it was needed. And that could cause complications sometimes in the code. And also the negotiated media formats they're grouped together on this single pipe as well. So here's a diagram a real simple diagram of the old media flow. Basically you just have an endpoint Bob dialing in and sending the single audio and video flow over that single internal pipe, and then coming in and then going back out on the other side to the connected endpoint or whatever endpoint's participating in the bridge. All right, so now that we've talked a little bit about how things have worked in Asterisk up to Asterisk 15, prior to Asterisk 15, I should say, we'll talk a little bit about how things are, what we've done to change and how things are working now in Asterisk 15. So streams, what kind of are they? In Asterisk, they represent a flow of a single type of media, like a flow of audio or flow of video, for instance. They're bidirectional, they have meaningful names, and the media formats are per stream. But something you couldn't easily do before was add, remove, and update the flow of the media, and with the new stream architecture, you can do that. And speaking of that architecture, so there's a few things that were needed to facilitate these changes, and we laid down a few requirements that would help us with the changes that we're currently doing for Asterisk 15, and also to make it easier as we're moving forward. As I said, this is kind of more of the beginnings and foundational work. So of course, like any changes to a code base, the less changes you have, the better. The API needed to be simple and fast and flexible. And functionally, though, the implementation had to be able to handle the renegotiations in order to add and update and drop streams. And this, of course, would be a basic requirement for a conferencing app, which Josh will talk about here in a little bit. So this is kind of getting more into the details from a Asterisk developer's perspective. I won't talk too much about this, but if you do develop for Asterisk, just know that we have written a nice kind of clean API for to use and to access, and it makes things, as I mentioned a second ago, easy to use and flexible. And that's really all I guess I'll say about that for now. All right, so multi-stream users. What do we mean by multi-stream user? Well, that'd be any subsystem or channel driver that wants to use the new multi-stream architecture and the new APIs that we've developed. But there's each of those users, like channel driver or whatever, they're going to be responsible for a few things that they have to be able to do and handle themselves. So for instance, they have to be able to handle the negotiations, and that includes renegotiations, and constructing the streams and the stream topology from the result of those negotiations. Then the topology needs to be added manually onto the channel itself. And it also has to be able to handle reading and writing of frames into and out of the streams via the new API. There's a couple examples of new API calls at the bottom there. So what in Asterisk has done this, or what channel driver has done this? PJ-SIP is currently the only channel driver that we've modified to support the new stream architecture. So the reading and writing of SCPs was modified to handle the adding and removing and updating of the streams. Callbacks were implemented to handle the reading and writing of frames in and from streams, and also a couple of new options were added to kind of limit the maximum number of streams, video or audio streams you could have on a particular endpoint. All right, so as I kind of talked about earlier, is a little bit about testing. We have all this new stream stuff, so we created an application in Asterisk to help us do a little bit of testing. So this new dial plane application is called AppStream Echo. It works similar to App Echo, as it's just the media is just echoed back to you, but this application is multi-stream aware. So based upon the parameters you give it, it'll add and renegotiate up to n streams for a specific type. And then it's echoed back, and then the media is echoed back, is received on the first stream, and then the type for every other stream that has been added. So for instance, if the endpoint calls into application with one video and one audio stream, and then you specify, you hand AppStream Echo, you specify 4 or like 3 or 4 streams, whatever you want, of type video. Then once it's been renegotiated and that renegotiation has been accepted, then you should see echoed back to your original audio stream, your original video stream, and then the number of specified of the video streams, whatever. All right, before we move on to the next section that Josh is going to be discussing, wanted to briefly talk about where this leaves legacy users. And legacy users are those subsystems and channel drivers that are not multi-stream aware. So this has kind of been the fulfillment of one of the requirements we put forth on the previous slide, if you remember, one of the previous slides. There's the one about having the least amount of impact possible. Basically, the legacy users are unaffected and continue to act as before. They still act as a single pipe, but that single pipe stream has been converted to a stream itself, and it's created automatically kind of behind the scenes when and where appropriate. As well as they have no knowledge of the new stream support, and they continue to use the old APIs, and there's a couple examples of old API calls there as well. Also, legacy video support, it's in a similar situation. Has not really been changed. We have done some updates to the video stuff, but you can still do all the same good, fun things that you used to do with video in Asterisk. So you can basically do like recording and playback and stuff for those formats that support it. And you can also do things in the bridge as well, in a conf bridge, for instance, like follow the talker is an example of something that you used to be able to do and you can still do. So anyway, that's pretty much how things have worked, how things work now, and then the stream architecture that we've put in place in Asterisk 15. And now Josh is going to come and talk a little bit about the bridging and what's been changed with regards to that.
So yeah, streams in Asterisk aren't really useful until something big actually uses them. And the first thing we've taken to actually updating to add support for multiple streams is bridging. And bridging is that thing that we all probably use every day without realizing it, and it's where you connect channels together so they can talk. And the two that we focused on is Bridge Simple, which is used if you have two parties. So Alice calls Bob, they're talking to each other, everything's happy. And this is what Dial uses underneath. And the other one that we've updated is Softmix, which is what ConfBridge uses underneath. And ConfBridge itself is really just a set of handy features on top of Softmix. So if you have like the IVR solution where you can mute and unmute, or the CLI commands to mute and unmute people, that's a feature ConfBridge provides. The actual mixing and stuff happens underneath using Softmix. So there are some other bridge modules that exist, such as Bridge Native RTP, which allows reinvites to happen to allow media to go directly between endpoints. And it also has a nice feature where it can optimize things internally. Those have not yet been updated to take advantage of multi-stream, but they do still work as they did before. So let's take a look at how simple bridging now works. So when Alice and Bob join the bridge so they can talk to each other, the first thing we do is we check to see if there's a channel with fewer streams than the other, and then we try to renegotiate it to add the missing streams. And this is really to provide the best end user experience, because if I'm Alice and I join a bridge with 4 video streams and an audio stream, I'd like to at least try to get Bob to match that so more media can flow and the experience is better. However, if it's the same number of streams on both sides, which is usually the case, we'll still try to reinvite the second channel that joined to match the first, just in case there's state differences or codec differences. We'll try to be a little bit smarter there. And then we map streams 1-to-1. So I get audio on stream 1 on Alice, I'll send it out audio stream 1 on Bob. And we really just act in Bridge Simple as a simple forwarder based on this information, based on the number of the stream. So here's an example of a situation where we have 2 PJ-SIP channels, which, like Kevin said, supports multi-stream. So we got some audio from Bob on stream number 0. We wrote it into the bridge. The bridge looked at its mapping and saw that, hey, this maps to stream 0 on Alice, which is also audio, and it just writes it out. And this also occurs for video. In the legacy case, like Kevin said, the core itself transparently adds or represents the legacy stuff with streams. So SIP-Bob in this case is a ChanSIP channel. It does not speak multi-stream, so it still has that single pipe between itself and the core. But the core, on its behalf, splits that out into streams. So when audio comes in, that gets mapped into a stream. In this case, it's audio 0. When video comes in, it gets mapped into video 1. And the bridge behaves just like it does if both channels support multiple streams. So it does the mapping like it did before, audio 0 to audio 0. Softmix is where it gets more interesting, and this is where the fun stuff occurs, in that multiple video streams can now be sent to participants in an SFU configuration. So for those who are unaware, an SFU, Selective Forwarding Unit, it picks a subset of video streams to forward based on policy. The only policy that we currently support is the options that Kevin mentioned to limit the maximum number of streams on an endpoint in PJSIP. So you can say, this endpoint can only handle 10 video streams or 10 audio streams. In the future, I'd expect other policy options to be added, along with programmatic options. So using ARI, being able to control things in finer detail, or via conference configuration. So you can say, these people who join should always be viewed, and go from there, along with talker detection like before. And there's no server-side transcoding or manipulation. The payload, the video payload that we get is the video payload we send currently to each person. So softmix can't be as simple as bridge simple, because in softmix, there can be multiple streams numbered 0. So to give an example, if I get video on stream 1 from Alice and video on stream 1 from Bob, I can't send both of those video payloads out video 1 on Charlie, because those are logically 2 different streams. So they have to go out 2 different streams on Charlie. So instead, what softmix does is it maps the streams on each channel to a unique internal identifier. So stream 2 on Alice might actually internally in softmix be represented as stream 78. And that's how the unique mapping occurs. And this occurs the other way too, for frames that are going out to a channel. However, audio is still the same experience as before. We haven't touched that. It's still mixed server side, and you still get all of the features that you would have had previously in softmix. And the really nice thing is that right now this only requires a single option to enable in ConfBridge, and that's video mode equals SFU. There's no other configuration options currently in ConfBridge to enable it. So like I was talking about before, this is what it looks like in an SFU flow. In this case, PJSIP Bob sent in some video on stream 1 into the bridge. That got mapped to an internal unique identifier of video stream number 32. And the bridge then sent that to Alice and Charlie. In Alice's case, her mapping says 32 goes to 2 for me. And in Charlie's case, the mapping said 32 goes to 9. Sure, Alistair. There is logically only one flow. I tried to represent this a few different ways, and this was the easiest way to do it. But there still is only one internal bridge. So we have an SFU in ConfBridge, and we needed a way to actually test it. I don't know if anyone's been involved in video hardware endpoints, but SFU isn't really their thing. So we opted for WebRTC because it was the quickest option for an implementation, and it can provide the best rich experience for a ConfBridge SFU. But WebRTC carries some things with it that we needed to implement to actually do this. The first being bundle. Google Chrome right now doesn't use the method that a lot of things are moving to represent multiple streams when communicating with the browser. They do a old mechanism that came from Google Hangouts era called Plan B. And while they are working on moving to the normal approach, which is called unified, and it's the way traditionally media streams are represented in SDP, they haven't yet moved there. So we needed to add bundle in order to support Google Chrome. And bundle is really just a way of having different media streams all use the same underlying way, the same underlying transport. So in most cases, that's a single UDP port and packets going back and forth. And even if you're not using an SFU configuration, if you're just doing audio and video, this is still beneficial because it can cut down on ICE and DTLS negotiation time because it only has to happen once. For SFU, however, it's really nice because you can just add in a stream immediately and you don't need to do ICE and DTLS negotiation again. And this is now available in PJSIP. So we've improved WebRTC support in Asterisk itself. Now we needed a client. And we named this Cyber Megaphone because everything's better when it's mega. So there is limited example code of this available. It's on GitHub under the Asterisk project, and it's under the MIT license. It's pretty much what you'd expect it to be. It's HTML and JavaScript. It's JS-SIP based. So it establishes a WebSocket back to Asterisk and speaks normal SIP. And it adds and removes video as participants join and leave the conference bridge. But we got a little fancy, as C developers can sometimes in webland, and we added controls to mute and unmute as well. And currently Firefox and Chrome are both supported for that. So we've laid the foundation groundwork for better stream support in Asterisk. It's by no means complete. There's a lot of areas that we can improve, and this is just a few of them. So how many people have used video support in Asterisk before? Have you ever noticed how if you want to do a video call, it always has to be a video call from the beginning, or else stuff just doesn't work well? Because of the renegotiation support that's been added to the core, we can actually add support for adding and removing video mid-call, as one would expect. As well, because we've got proper stream support, we can also add better video recording and playback. So we might be able to store those in containers, such as an MKV file. So here's a nice scenario that could be possible in the future. If I'm in a ConfBridge SFU scenario, so I'm in a video conference with 3 other people, I could actually store that video conference with video for each participant in a file, and then later, if I wanted to, play it back. Or if I needed to extract someone, I could use an outside utility to pull that stream out and store them individually too. And one thing that WebRTC is really focused on is the end user experience. So in video quality, out of order, packet handling, packet loss, we all know it, the internet's not perfect. No network is perfect, as much as we would like to think that sometimes. So right now, Asterisk has pretty basic support for that. We've improved the way that we handle sequence number gaps. So if some packets get lost along the way, we'll pass that along now, which helps browsers, for example, make better decisions. But there's tons of things that we can do there to improve handling of that, which will improve the end user experience too. And this is by no means an exhaustive list. I actually sent out a dev post with a wiki page that details tons of more stuff where streams would really be cool in Asterisk and how things could be improved. But this is some good video stuff. So putting it all together, we have streams in the Asterisk core. We have streams in PJ-SIP. We have SFU video conferencing in ConfBridge. And we have a WebRTC client that we can actually use to test all of this. So let's be dangerous and do a demo. Disclaimer, this is not dangerous demos. You can check that out this afternoon. Go for it. Hey, Matt, you want to join us? I'm going to be crazy here and have a mic in one hand and a laptop in another. So this is Cyber Megaphone. This is a 3K version. It's got a few more additional features and it looks a little bit better than the version that's up on GitHub, but they're pretty similar. So if someone else, this room does have a cap of 5 people in it, but if anyone in the audience would like to join us, you may.
You want to do the doorbell?
Yeah, let's do the doorbell. We also have a legacy device too.
It's going to get some reverb maybe?
That's okay. I'll log in and kill it.
Yeah, so this is a T-Com doorbell that you could use at your house or something. And we have it connected so it will basically dial into the conference. Let's hope it is. I hear it.
Oh, yeah.
There it is. Nice fisheye lens.
Yeah. And
Yeah, some people are moving there.
oh no.
Unfortunately, you can't hang it up from this device. It just either times out or you have to kill it from the CLI. There you go, Josh.
There we go.
And it should go.
Yeah, and
away.
because this is ConfBridge, I can just log in and do ConfBridge mute all, thankfully. So as well, the doorbell is speaking H.264, and then the rest of us are doing VP8 or VP9. I can't quite remember what I have it configured as, but we do have different ones. And we can also do,
Somebody else is coming in.
hello.
Hey, we got another participant.
I can also do, if you go down a bit, Kevin,
I don't know if anyone else, that's the max participant. Oh, yeah, no.
I can also do a screen share. It's my Spotify. Please don't judge me.
I think
If you have song recommendations, feel free to tweet them at me. Shameless plug for my Twitter account there. And I can also stop sharing. And then I'll be back in a second. Hello. So that's Cyber Megaphone. Any questions? Go for it, Alistair.
Seems like there would be a lot of applications in the television industry for this, for distributing their video streams. That was
I've never thought about that, actually. It would be interesting. Definitely. Let me hang up the doorbell. Yes, that is the thing about doorbells. Hang up. PJ Sip. Doorbell. Goodbye, doorbell. Also, this server is on the public internet, so it's getting attacked right now, which is quite interesting. Remember, people, putting Asterisk installs on the public internet can be dangerous. So,
Got a question while I don't mind. So, if I understood correctly, you guys support the unified plan and Asterisk that you mentioned, and it's cyber, right? But also supports the world. But you guys mentioned the SDKs of the unified plan, or does Asterisk support like receiving unadvertised media from unadvertised?
so the question is, Asterisk supports unified plan, which is the normal way in SIP, basically, of communicating multiple media streams. But Chrome does Plan B, and how do we handle that? We're munching it on the client side. So to Asterisk, it always sees unified plan. We're using a fork of your guys' SDP interop JavaScript library, which works for us. So we haven't had really any there's been one minor tweak we had to do to support screen sharing, but otherwise it's worked perfectly fine. Any other questions? Go for it, Brian.
Expose any of this through ARI yet?
So the question is, do we expose any of this through ARI yet? The answer is, before the 15 release, I worked on adding support for this to ARI. My first stab at it was interesting, so I took a simpler approach. And when you create a bridge in ARI, there's now an option for a bridge type called Video SFU. If you use this feature, you'll basically have the same experience as ConfBridge without any of the features. You can add them if you want. That's currently the only option in ARI. But in the future, I would fully expect ARI to gain additional operations to provide a richer video SFU control experience that a developer would expect. But as is most things in ARI, they won't be, what's the word I'm looking for? They won't be overly complex or anything. They'll be easy to digest. Any other questions? Going once, going twice. Sold, because this is MIT code, and you can go and try it if you'd like. Actually, the Cyber Megaphone repository also does have a README that gives you the instructions of how to set up Asterisk a little bit, and also all of that stuff. So if you guys would like to try this, you can download Asterisk 15, look at that repo, and give it a try yourselves, and see what you can create. Manager Matt would like to say something or ask a question.
Also, there's a great blog post on blogs.asterisk.org.
Yes.
Comprehensively how you set it up and how you do it.
Yeah. How many people were aware that the Asterisk development team actually has a blog? That's not bad. So if you go to blogs.asterisk.org, we post every 2 weeks. It's not like a marketing-driven blog or anything. It does get technical. And so Kevin did write a pretty awesome blog post about how to set up Cyber Megaphone and Asterisk and use this stuff. So if you'd like some further help, it's a great blog post to see. And as we've been doing the blog for probably, I don't know how long now, a year or more?
Definitely more.
Definitely more, apparently. Time flies. There's lots of great content on there, so take a look and you might find some interesting stuff you didn't know about in Asterisk. Any other questions? Going once, going twice, going 3 times, once more. And we're done. I'd like to thank you to myself, moderator to presenter. And if you do think of any other questions that you'd like to ask us, feel free to stop us in the hall. We'll be here the rest of the day. Thanks very much.